So if you remember, I said that I will not derive the formulas, so no derivation. Okay, if you are interested, you can go and check yourself. Okay, but I don't have time to derive the formulas. But I will start with the angular velocity, which is the change of angle with respect to time, and then compare it to. So this one is very good for comparison and then understand things. Then the change of speed, the distance with respect to time. This is the angular velocity. And then we have the angular acceleration, which is alpha. Let me use a different color here. And then I have the. Okay, so before moving to alpha, you see the ds. Okay, and then we have the ds here. That is r d theta. And that's the arc. This one is just, this one is a trigonometric relation. And then we have, let me add this one, the angular acceleration alpha. That is the change of velocity, the angular velocity with respect to time. And then compare it to the acceleration that we have, the change of velocity with respect to time. Okay. And then you can see here that this is the angle that we have. The body rotates, and then as it rotates, it travels at the angle d theta. So this one is the angle. Okay. And then I should add it here. The omega is the angular velocity, and then alpha is the angular acceleration. You can also write this alpha as the change of angle with let me use a different color. The angular acceleration, you can also write this one as the change of angle with, you take the differential two times, and you can compare it to the acceleration, that is the change of position with respect to time. Okay, and then let me add one more slide because I will have a couple of more formulas for this one. Okay, so then these are the main formulas, and then we have the for constant acceleration alpha. Okay, in that case you can see that alpha is alpha c, and then we will have the omega, that is alpha, so initial omega plus the alpha constant into t, and then we will have the theta, that will be theta 0 plus, let me add this, theta initial plus then omega initial times t plus 1/2 alpha c, and then times squared, and then we will have the omega squared will be equal to omega initial squared plus 2 alpha constant theta minus theta initial. Okay, again you can compare these ones to, again, particle kinematics. And then you will notice that you have the same formula for this particle kinematics as well as the rigid body dynamics. The formulas are same, but except you have the different variables here. And then one more thing here is that I should add it, that the velocity is omega cross with the position vector RP. Okay, you can see this is the RP to any point on that rigid body, cross with RP with the omega, which is the rotational speed. You can see the omega rotational speed, and then you get the velocity. And if you check the units, so that this one, the first one is meters per second, and then you have the radians per second, and then you have the meter. Okay, and then note is that radian is not dimension. And then you can see that this one is gives you the meters per second from the both sides. Okay, so these are the main formulas. And then let me just add one more thing about this RP, is that this RP is from axis of rotation. So let me add it here, any point from axis of rotation. Any point on axis of rotation. Okay, as always, we will use the right hand rule. Okay, so when you take the cross product, we always use the right hand rule. Okay, so this is about the first part of the formulas, and then we have the similar to the circular motion. We have the normal acceleration, and then we have the tangential acceleration. And then for these ones also, I will just write the formulas, and then no time to derive the formulas again. So the acceleration again will be change of velocity with respect to time. And then we have the normal acceleration, and then we have the tangential acceleration. As you can see here, if we add the normal acceleration to tangential acceleration, we get the resultant acceleration. Okay, and then this is what we have got. And then one more thing here is that we have the tangential acceleration that is equal to the alpha crossed with r. Okay, and then the normal acceleration is negative omega squared r. And these are the main formulas that we will see for a rigid body rotation about a fixed axis. Okay, as you can see, we have lots of cross products. You have to again review the cross product section of the book, and then I believe you will understand the concepts much better in that case. I will stop the recording, and then next part I will talk about the gears and then the velocity in the gears.